Welcome students to EduCell. So today's session is all about we will read about iteration method, which little bit moderation of the easiest method which we recently completed. So here you can look at a question. In first, you can say the first question will be, suppose t of n is 2t n by 2 plus n. Simple question. We'll start with little bit modifications. We instead of 2, it's better you can write 3. Okay, now how to solve them? Simple step, that which is unknown, the unknown term is n by 3. So to find n by 3 you need to put the value in n. Okay, 2 n by 3 by 3 plus, instead of n also you have to write the value which you have taken as n by 3. Simple. Next, to simplify this, to n by 9 plus n by 3. Now the unknown term is tn by 9. You need to find tn by 9 is, you put this value in n. Okay, there n, there also in n. To find a pattern first. Okay, 2 t n by 9 divided by 3 plus n by 9 after putting the cost directly. Okay, your target should be t of n only, you do not focus anywhere. Okay, now 2 t n by 27 next plus n by 9. This is how your target should be. Okay, better you try to substitute all the value and you try to iterate. This is not uh, substitution, this is iteration method. Substitution method you will read where guesses are to be taken, where mathematical inductions are to be done. Okay, so here let us start with t of n, and we are trying to put the value of t n by 3. I'm just writing it, plus n by 3. The value of n by 3 is, we have to write here only. Okay, like 2 n. Okay, 2 tn by 9 plus n by 3, we have to write 2 tn by 9 plus n by 3. Now you keep the cost as it is, because we are not going to touch that one. Here also the cost as it is, because we are going to expand the value only. Okay, nothing will be expand excluding that one. 2 square, then t n by 3 square, I'm just writing instead of 9. Now 3, because 2 is getting multiplied here, so 2 is getting also multiplied here. 2 into n by 3 plus n. Okay, here it is within a bracket we are writing, so these are the value. Now t n, the value of t n by to n by 9 is 2t n by 27 plus n by 9. That we are going to substitute now. 2t n by 27 plus n by 9 plus 2 n by 3 plus n. We are just keeping as it is. Okay, now 2 square will be 2 cube n by 27 plus 2 square into n by 9 plus 2 into n by 3 plus n. The number of practice if you go for, then only it will be very easy to understand. Okay, now we are somehow approaching the contents, the approaching the patterns of it. You can check now. T of n will be equivalent to 2 cube t n by 27 plus 2 square into n by 9 plus 2 into n by 3 plus n. Okay, this much. Now I'm trying to do it as a cube. Let us think. Okay, let us go for an approach to find a pattern. So 23 is 3 to the power 3, that we know. So instead of 9 we can say it's 3 to the power 2. Okay, that could be possible. Again, if you want to simplify that, cube t n by 3 to the power 3, because 27, instead of 27 we are just writing it, I'm just writing it as 27 now, just for better idea. It's only 2 square, which is 9, that we have already gone for. Here you can write 2 by 3 square, definitely it is done. Now n 2 by 3 to the power 1, it could be done. 2 by 3 to the power 0, because nothing is there, 1 is there, anything power 0 is 1. Okay, we are trying to find a pattern. So here what exactly being done, 3 3, but here it is 2, here it is 1, decreasing 1. Okay, so to if you are running for k times, suppose running for k time, for k times, t to the t of n is 2 to the power k t n by suppose 3 to the power k. Okay, that k times, but it is 3 and here is 2. The 2 is definitely minus 1 of the 3 which we have written in the front. You can write that 2 3 k minus 1, because if it is k it should be k minus 1. Like if you can put the value of 3 also, everything will be correct as it is. Now 2 3 k minus 2, like this we are running it. 2 3 uh, 1 and 2 by 3 0. Okay, like this we are actually running. These are the cost part of it. Now you can assume, once you are running towards k times, you should go for the assumption. Assume you have reached the base condition. The base condition we have to take is, suppose base condition you can say it is t of 1 is 1. Suppose t of 1 is 1. So in this you have reached the base condition. You directly write it, the base condition if you are writing. So the function is 3 to the power k is 1. Okay, now you can write the value inside that is this one. So to simplify, n equal to 3 to the power k. Okay, it's suppose, let us take this as your equation 1. We will discuss. Okay, just for a moment, I'm keeping this as a box. Okay, this box is your equation 1. Clear? And this is equation 2 for 3 to the power k is n that we said. Okay, next, to find the value of k, I told you you can take the log with the base क्या लेना है, base, this one you can take the base. If you can take the base of 3, then 3 base 3 log 3 base 3 will be cancelled out by giving the answer as 1. Okay, so you can take both the side, log base 3 you need to multiply to find k value, 3 to the power k. Then what you have to do, k is, if you need more simplifications also, I'm writing that one, log n base 3 equal to k, because this is a property of log 3 base 3, it is 1. Clear? Next, k value will be log n base 3. Log n base 3 depends on what the power, or like on which power the k is exactly. On that basis we found log 3 could be a better option for us to cancelling out with a 1. Okay, that is why we said and said this is equation 3. Okay, now substitute the value of k, the value of k in equation 1. Okay, if you want to substitute that one, so t of n will be now to the power k we have written t n to the power k, sorry, 3 to the power k plus n to the power k minus 1 plus n into 2 to the power k minus 2 dot dot n into 2 3, you can say it's 1 n to 0. Okay, this is what you found. Now you are substituting in this equation. Once you are substituting 2 to the power k, we said is there is nothing we mentioned, so k, the value of k is 2 log n base 3. The k value we are substituting now here in t, that we say t 3 to the power k is n in equation 2. In equation 2 we said n equal to 3 to the power k, so you replace that one. Now you take common, okay, and write as it is. I'm just changing the order from decreasing to actually increasing. So 2 by 3 k minus 1, suppose k minus 2 plus 2 by 3 k minus 1. I'm just changing the order only, okay, to make it simplify. And one thing you should know, in log property, once you are writing on the top of it, the value will be changed, interchanged. Okay, the value will be interchanged, like n will be in place of 2, we can write n, and in place of n we can write 2. This is a property of a log. Okay, now t of n will be n to the power log 3 base 2, and t of n by n is 1. Okay, then plus n. Here, as for the GP properties, what we have to do, we have to find a, like we read a by the r condition. Yeah, here the r is 2 by 3. Whether 2 by 3 is less than 1 or not. Yes, of course it is less than 1. If it is less than 1, then what we have to write? If it is less than 1, a is nothing, it is 1. So 1 you have to write 1 by 1 minus, if it is less than, the r value is less than, if I'm just writing that a by 1 minus r, if r value is less than 1. Okay, a r minus 1 if r value is greater than 1. This is the condition. Okay, so as per this note, we are using that GP. Here what we have to write, 2 by 3. Once it is done, now you simplify. T of 1, as per the base condition we have declared, as per the base condition T of 1 is 1. Now, so n to the power log 2 base 3 plus n 1 by 3 minus 2 by 3, then 3 will be on the top, n log 2 base 3 plus 3 n, directly I'm writing. Okay, so here we definitely say the value that here the power is 1 here, and the power is log 2 base 3. So based on that, we can find the time complexity could be big of, out of this, from this we can write the time complexity here is big of n to the power log 2 base 3. This is a theoretically correct, but for practical, if you want, so that should be written plus c into n. Okay, that we have to write in practical, but theoretically it is correct. Now for another example, little bit moderate example we are taking, where it is Simply I'm just writing it like tn minus 1 plus log of n, log n you can say, where base is 2. Then how to solve? Here the unknown term is n minus 1. We are just writing n minus 1 minus 1 plus log n minus 1 base 2. In place of n, we are replacing the tn minus 1. Okay. Next, tn minus 2 plus log n minus 1 base 2. And again, for this unknown term, we are writing n minus 2. Then we are putting the value directly in place of n. And here also in place of n only. We are not changing anything. Okay. So tn minus 2 minus 1 plus log n minus 2 base 2. Simplify that one, n minus 3 plus log n minus 2 base 2. Okay, so these are the value we got. Now you substitute each by values one by one by writing this one, tn minus 1 plus log n base 2. Then the value of this t of n will be the value which we found here. Okay, that you write without changing the cost. Okay, so tn minus 2 plus log n minus 1 base 2 plus log n base 2. Okay, now to put the value, you take this value and you put it here. Here will be tn minus 3 plus log base 2 n minus 2 plus log base 2 n minus 1 plus log base 2 n. So like exactly what we are doing, what we are finding. So there is a value we found somehow pattern. यहाँ पे 3 है, यहाँ पे 2, 1, कुछ नहीं है. So like if we are running for k times, it's reducing somehow. Okay, so let us assume that running for k times, if you are running for k times, the value of t of n will be tn minus k plus log base 2. Here you can write n minus k minus 1, then log base 2 n minus k minus 2 plus up to log n base 2. You can ask me why you are writing, sir, in this way. You can check. If it is 3, it is 2. So if it is 3 and here it is 2 and here it is 1, so if I'll say the k is 3, suppose k is 3, if I'm saying I should write for 2 k minus 1, or next one I can say is k minus 2. Simply I'm writing in that order. Okay, k minus 1, the previous value will be like this, up to how much we are running, like up to log of n. Okay, then here you can go for assumption. Assume we reached the base condition, where the base condition is this much. Here might be I forgotten. The base condition we have to write is the base condition. Suppose t of 0 is 0. Suppose this is the base condition. Okay, for the base condition, we reached the base condition. Now the function is tn minus k is equivalent to the function of base condition. Now you can add that value, n minus k is 0. Now the value of k is n. Simple. This is your equation 2, suppose, and here the value which you got for this function is your equation number 1. Okay, now you substitute the value. value of k in equation 1. Done. Now what is happening? Tn in place of n, in place of k, you can write n as per the equation 2. Next, log n minus in place of n, k, you just write n. Next, log base 2 n minus 2, okay, plus dot dot plus log n base 2. Simple. Okay, now n minus n is 0. Okay, t 0 plus log base 2. If you uh, expand the minus 1, uh, it would be like n minus n plus 1, then log base 2 n minus n plus 2 plus dot dot up to log n base 2. This is simple now. Okay, here we know the value of t of 0 as per the base condition, it is 0. Okay, t of n, now you can write 0 plus log, here also we can just cut that one, log base, log 1 base 2, log 2 base 2. Here the 2 is written, here 1 is written, that's why you can say log 3 could be the next one, like up to log n base 2 you are writing. So you can simplify further, you know, plus is there, so everything will be multiplied. Once you are, this is a property of log 1 into 2 into 3 into 4 dot dot up to, you are multiplying up to n. Okay, and 0 we are just removing that one. Now what will be there? So this is n factorial, we can say. Instead of n factorial you can write n factorial. This is a correct answer, also not an issue for tn. Okay, this is the correct answer. Also the upper bound we are writing n to the power n, which is super polynomial. Okay, super polynomial we are writing. So in that case what will happen, like suppose you are writing n factorial, it should be a greater, if you are writing, the correct answer will be log 2 n to the power n if you are writing. So as per n to the power n, the log property it has to follow, then t of n will be n log n base 2, because n to the power n we are writing maximum upper bound, or you can say the upper bound is the highest upper bound we are getting is n log n we are getting. Why n to the power n? In factorial we are writing, if it is writing by if it is written by you, it's correct, not an issue. Instead of that n factorial, if you are writing n to the power n also, that is correct, because it is a factorial case, it's more than a factorial. So you are writing n to the power n, if it is n to the power n, so n log n you can write. Here the time complexity is, big of n log n base 2. Here the time complexity we decided as n log n base 2. So I hope it is understood by you all. So if any doubt, please comment below, and thank you for watching. Have a good day.